now this is Hanno Böck. I think a lot of you probably already know him because he's a well-known German journalist, and most of you probably have read something in a lot of magazines where he is writing something. And he will speak about TLS interception considered harmful. So this is about HTTPS, and this is not only encryption, it's also about identities and whom we trust and who decides whom we trust and how this can be attacked. Well, and have fun.
Yeah. So, hello. So TLS interception. This is a problem that came up earlier this year when there was a software called Superfish that got detected and that had a very severe security vulnerability. But this also highlighted kind of an issue that a lot of software pieces are doing this, and it's a quite questionable way of doing things. And I wanted to provide an overview about this issue and get a bit deeper into it. Quickly about myself, as she already said, I'm a journalist, mainly writing for the German IT news magazine Golem. But right now I'm also doing some IT security work for the Core Infrastructure Initiative from the Linux Foundation, and mainly I do fuzzing there. So I'm trying to improve the software that you're running on your computers. So I want to go a step back and talk a bit in general about TLS and the kind of discussions we had in the past 5 years, where we had a lot of vulnerabilities. You probably heard about some of them. We had Heartbleed, which had most attention, but also we had things like Beast, Crime, Lucky 13, Poodle. So many of so we got a lot of attention about the security of TLS, encrypted connections, and there are also some things to learn from that. One example was the so-called Beast vulnerability. This was already, when the Beast vulnerability was presented, it was already a known issue that older versions of TLS had some issue with the CBC mode, which is the encryption mode for the symmetric encryption. So there was already a fix available, but back then most people still used the old TLS 1.0 version. And still today, a lot of web pages only support TLS 1.0, and so the fix is, one possible fix is to use a newer TLS version that doesn't have this issue, and there's also a workaround where you can, if you do a certain kind of splitting of your data packets, then this vulnerability doesn't happen. Then there was an issue called Crime, which was that due to compression in TLS, that would leak information about the data inside. And the relatively trivial solution is don't use TLS compression. It gets a bit tricky because HTTP also has compression and it has similar issues, and it's a bit harder to fix it there. But so what's also interesting here is, again, we have an issue that's part of the protocol. So it's not that there's a bug in the software, but it's the TLS protocol itself that had a security issue. And then we had Lucky 13, which was an issue with the way that TLS combines the MAC and the padding and the encryption and in which order it does it. So generally today we consider it the only safe way to combine the different things is to first encrypt and then do a MAC. So the MAC is there to guarantee that the package has not been manipulated. And there was a timing side channel, so by checking whether what kind of error occurred on a connection, an attacker could find out something about the key. And so the workaround about it is do everything timing safe, but this is very hard. And the solution would be not to use these encryption modes anymore that have this weakness. And there's currently only one encryption algorithm in TLS specified that doesn't have this weakness, which is AES in the GCM mode. And there's also RC4, but that has other weaknesses, so we don't want to use that as well. And then there was POODLE, which was a vulnerability in the very old SSL version 3, which kind of was, okay, it shouldn't be a problem because it's so old, nobody should be using it, but a lot of people were still using it, and there was also a downgrade attack you could do. But then there was something interesting, that there were some devices that actually had the same vulnerability also in TLS, because the issue was that in the old SSL version 3, there was a padding and it was not defined what's inside this padding. So you could have arbitrary values in that, and that somehow could be used for an attack. So TLS defined that this padding must be a specific value, but some implementations didn't check that. So they managed kind of to port the vulnerability from the old protocol by doing a bad implementation to the new protocol. So, and then we had some debate about something called forward secrecy. That's a feature of encryption technologies where you generate a key for each connection. And the idea there is that you destroy that key after the connection, and then if your private key later gets stolen, it doesn't have such a high impact because the connections from the past still cannot be decrypted. And now there are modes in TLS that have forward secrecies and others don't, but there's really no good reason not to use forward secrecy. And it's now also agreed upon that the future version, TLS 1.3, will only have forward secrecy modes, and the modes without forward secrecy will be removed. Yeah. So that's kind of the debate we had on TLS in the past years. There were some more vulnerabilities, but some of the lessons to learn here is that we have security bugs in the protocol, which means that even if you implement the protocol as it's written in the standard, you may have security vulnerabilities. So you need to know about all these workarounds and what to disable to have a safe version of TLS today. And only the very latest TLS 1.2 with the GCM mode and with forward secrecy is really considered up-to-date crypto and considered safe these days. But you still need to support more or less TLS 1.0 because there are still so many servers in the internet that if you would disable that, you couldn't serve a lot of web pages. Yeah. But that's kind of tricky because you have these timing issues and these record splitting issues. So if you want to do that safe, it's quite complicated. And then we have this problem with certificate authorities. So as you probably know, if you want to have an HTTPS web page, you need to get a certificate, and there are hundreds of these certificate authorities. And all these certificate authorities can have sub-certificate authorities. So we don't even really know how many there are. And in the old system was that basically every CA could issue a certificate for every domain. So this has the impact that the whole system is only as secure as the worst of all CAs. So if one gets breached, everyone has a problem. And this also has the impact that it doesn't really matter which CA you choose. So if you say, I go to a CA that's especially trustworthy for whatever reason, that doesn't really make any sense. And yeah, so, and this also had practical implications. We had a lot of cases in the past years where certificate authorities issued certificates like for Google.com, but not to Google, but to someone else. There was many issues with Komodo, there was Turk Trust, there was CNIC, the Chinese government-controlled CA, there was India CCA, there was DigiNotar, which later went bankrupt, ANSI, which is a French government-controlled CA. So they're for quite different reasons. So some of them were hacked, some of them, like there was an issue where this Chinese CA sold a sub-certificate to an Egyptian company that then used it to intercept traffic in their own network. But all of them, so we had a lot of issues where these CAs didn't follow the rules and issued certificates to people who shouldn't get those certificates. And over the years, there have been many debates about how we could fix this. And so there was an idea called sovereign keys, which was interesting but quite complicated. There was a talk on the Congress a few years ago. There was TAC, which was a kind of key pinning proposal. There was convergence, which the idea was to check a certificate from different points in the network, and Dane, which is based on DNSSEC. But all of these solutions have in common that none of them ever got really deployed widely. But recently, there's now a standard called HTTP public key pinning, which I like a lot. And the idea there is that a web page can say, okay, this is the key of my certificate, and here's a backup key, and the browser should store this key and the backup key. And in the future, only these keys are accepted for this web page. So we have kind of, additionally to the certificate authorities, we have a trust on first use system that, not every CA can issue a certificate for this web page that can later be used for attacks. And also the browsers these days contain some pre-pinned certificates. So for example, if you create a bad certificate for Google.com, it will not really work, at least in Chrome and Firefox, because the browser already knows that Google only gets certificates from Google's own certificate authority, so you cannot use a random certificate authority to issue a certificate for Google. The problem with that is a bit that it's not widely used. So there was recently a statistics about the Alexa top 1 million web pages, and only one of them was using this key pinning header. And at some point there were 4 pages, and now it got down to 1. So it's really not widely deployed, which is unfortunate because this is really a very big improvement of the security of the TLS system. And then there's a concept that's mostly developed by Google, which is called certificate transparency. And the idea here is that we have a public log that's append only, so it works a bit like Bitcoin, that can be verified by anyone who wants to, and that has all certificates in it. And the idea is to have several of these certificate transparency logs. So that's a very promising idea. So it doesn't prevent attacks with wrong certificates, but it pretty much makes sure that you cannot hide these attacks. So there's a very high likelihood that if you have certificate transparency in place, that all attacks will be detected at some point. And it's not really widely deployed, but Chrome has some preliminary support, and Google plans to require it from at least for the so-called extended validation certificates and later for all certificates. So there are some things happening in this space to mitigate these problems with certificate authorities. Yeah, so finally, after many, many years where we had this problem, we have now some mitigations that are coming. But also the conclusion there is that if you want to verify TLS certificates, you need to know about these things, and your implementation needs to know about it, and you have to stay on top of the development, what's going on in TLS security. Yeah. And some late development is that a lot of people are pushing now for HTTPS everywhere. Google did a lot in this case, and also Mozilla now plans to mark HTTP pages as insecure generally. Then certificates are no longer an expensive thing, so there are no certificate authorities that give you a certificate for free. There are 2 now, and Let's Encrypt will start pretty soon, which we will have a talk later today also. And I think this is generally a very good thing. And I also think this is a good thing even if you don't have any secret data on a web page. Because what many people tend to forget is HTTPS guarantees that your data is transmitted encrypted, but also that it has integrity. So that means that the page the user sees is really the page that came from the server, and it was not manipulated on the way. So even if your data is not secret, you always want your data to be correct. Yeah, but there are also people who think that this is a very dangerous development. Like here's a picture I made on the Black Hat conference recently, where a company called Blue Code, you may have heard of them. They have some questionable approach to security researchers, that they say TLS traffic is pervasive and introduces risk. Especially, it can also be used for advanced persistent threats. So if anything is APT, that's really dangerous. Yeah, and obviously they sell you a solution for that. So they have a way to inspect your TLS traffic. And many other companies do as well. This is from F5, and this is, I don't know which company this is. I'll sell you some products that allow you to kind of inspect your encrypted traffic. So there are a lot of products that are doing this. Like we have these enterprise security solutions, like what Blue Code and F5 is selling. We have now antivirus software that's doing this. We have parental control or youth protection. We have some ad blockers or a lot of ad injection software, so which is usually the stuff that you don't want but may have installed anyway on your computer. So how do they do this? So the idea here is that so you cannot inspect or manipulate the traffic if there's HTTPS, because it's the idea of HTTPS to prevent that. So the solution these products have is that they install their own certificate authority root certificate into the browser. And then basically what they do is a man-in-the-middle attack on your browsing. And then earlier this year, there was this software called Superfish that some people found on their Lenovo laptops. It came pre-installed on Lenovo laptops. What this software did was that when you were surfing the internet, it analyzed the images and tried to find objects on these images, and then it would present you some ads that were related to these images. So, I don't know, you could surf a web page about camping, and then it would give you an ad about where you can buy a tent. So what this also highlights is that there's now this kind of very strange market that there are companies who are producing software that nobody really wants, but they are paying companies like Lenovo that they install it on their laptops. And what also happens is this software bundling, where you install some software and then the installer asks you with some very tricky UI thing that, do you also want this toolbar or this whatever? And then if you click the wrong button, you have something installed that you never wanted. But the problem with this Superfish software was that it used such a man-in-the-middle proxy, and it had the same certificate on all installations. And so also it had the same private key on all installations, and the key is naturally part of the software. So you could just extract this key, and like 2 days later someone did this, so the key was public. And with this key, you could basically attack everyone who is using a laptop that had this Superfish software installed. So yeah, was a big PR disaster for Lenovo. They later said, okay, we're sorry. They provided a removal tool. They then said, okay, we've learned from it. We will be more careful in the future. A few days ago, if you've seen this, Lenovo is now using BIOS rootkits to install some crap on your Windows system. I don't know if they have really learned anything. Yeah. But then it became even more interesting. Then people found out, okay, the Superfish was using a software module from a company called Comodia. And this was used in many different applications, and all had the same problem. All had this shared key problem, and people were extracting keys from many different products. So there was a product called StuffCop and Custodio, which was some parental control thing, and some VPN software, and then adware, which is an anti-adware tool. And there was also a lot of adware, like this stuff that gets installed on your system you don't really want, whatever. Yeah, so it turned out this problem was much bigger than the Superfish issue, that there was a lot of software that all had the same vulnerability. And then Filippo Valsorda, who's a Cloudflare engineer, he found out that there was a trick how you could create certificates that all of these Comodia products would accept. So first we thought, okay, you have a key for every of these products, but then there was kind of this trick, because what happened was if this software would connect to a web page with an invalid certificate, it would replace it with a certificate that was signed by this man-in-the-middle proxy, but that had an invalid host name. But what this software didn't consider was that certificates also have this field subject alternative name, where you can add additional host names for a certificate. And these were kept intact. So you could create a certificate that was signed by any CA or by your own self-signed CA, and then add the host name for the web page you want to attack in this subject alternative name field. And then every software that had this Comodia module would accept this certificate. And then I found this kind of ridiculous. Then Lavasoft, which is producing this adware software, they said on their Facebook page, yeah, Lavasoft's most recent release of adware Web Companion does not include this capability, so this Comodia SSL interception, but we are not yet able to confirm with certainty that the compromised component of the Comodia SSL digester has been removed. So there you have a company that's producing a security product, and they say, okay, we had a severe security vulnerability, and we don't know if we have really fixed it. And that's kind of a bit ridiculous. And it took me like 15 minutes to verify, okay, they were still vulnerable. I commented it on their below their Facebook blog posts. Maybe it helped them, I don't know. Yeah. And then a few days later, there was some IRC channel where people who were interested in this issue were chatting, and then someone posted a link that, okay, there was someone asking, he has a software called PrivDoc on his system, and he wanted to know if this is something like Superfish. And it turned out this was a software that was developed by a company founded by the CEO of Komodo. And what this software would do was it would identify ads that it considers as dangerous. It wasn't really clear why, what criteria, or that would impact your privacy. It would replace them with its own ads. So thereby they make money because they replace some ads with their own. And then I looked at it and found out, okay, it does not use a shared certificate. So it's not like Superfish. But what it did is it just accepted, on the other end, every web page certificate. So you could have a random invalid certificate, and the software would connect to it and replace it with its own certificate that was valid for the browser because it had its root certificate installed. And then also I looked at the traffic of this software, and it was sending every URL you were surfing to in clear text to some server from this company. And then, yeah, I wrote a blog post about this. It was pretty late in the evening, and then I went to sleep, and the next day BBC called me. So this really generated a lot of interest in the media, because the issue here was really Komodo, because Komodo is a company that's selling TLS certificates. That's the biggest certificate authority these days. And so the same company that's selling you the certificates for HTTPS security is related to a product that's breaking this security. So it was not a Komodo product, but they had some close ties. So Komodo was advertising this product, and also Komodo had a browser that was bundled with this PrivDoc, but this version in the Komodo browser was not affected by this vulnerability because that worked as a browser plugin and not as a man-in-the-middle proxy. But yeah, so yeah, we had another issue where this TLS interception proxy caused a severe security vulnerability. And then I looked at some other products that would intercept TLS traffic, and there are some antivirus applications, and I looked especially at Avira, Kaspersky, and Asset, because these were the ones that were freely available and I could easily test. And none of them had a severe vulnerability like Superfish or PrivDoc, but all of them had something that made the TLS connection worse. So the biggest issue was that Kaspersky was then still vulnerable to the Freak vulnerability. So Freak was a vulnerability where you could downgrade connections to some export mode from back in the 90s when it was forbidden to have strong crypto. And it was found, yeah, that somehow you can trick OpenSSL into doing these old connections. And very shortly, some days after this freak vulnerability was published, someone posted in Kaspersky's forum that, okay, you have this problem with the freak vulnerability, and it was ignored for more than a month. So I refound this issue in Kaspersky. And then I earlier told you about this key pinning standard we have now. So you might think, okay, if we have this key pinning, then these whole TLS interception proxies shouldn't really work, because if the browser has a Google certificate pinned, and then it gets replaced from some TLS interception, that shouldn't really work. But the problem there is that the browsers had to do some kind of compromise, because there's already so much software that does this TLS interception that they couldn't break all of it. So what they did is they said, okay, if there's a manually installed root certificate in the browser, then it would ignore that key pinning header. So it's not really nice, but you can kind of understand why the browsers did this. Now, what should happen if you do it right, then these products should test this header themselves on the back-end side. But none of the software that I looked at did this, and I have not until today seen any software doing this. So the takeaway there is like, if you're doing this, if you're doing a TLS interception proxy, then you are responsible for the security of this connection. And then it matters like how good is the implementation of the TLS and how good is the implementation of the certificate validation. And the question you have to ask here is, are these companies who are producing these products qualified for that? And my answer to that is probably not, because browsers have large security teams and they are very involved in the debate about TLS in general, and so they follow up what's kind of state of the art in encryption, and a company that's producing some strange superfish software probably is not. And then under this blog post about the antivirus application, someone asked me the TS software called AdGuard that also installs some certificate and if I can look at it. So I did that, and then I found out, okay, it created a new certificate on every installation, but it always used the same key. So that was a bit strange. Then later I found out, okay, so I then contacted them and got a reply from some of the developers. What they did was that they choose 1 out of 8 keys that based on your CPU. So the idea was if you reinstall it on the same system, you get the same key. Doesn't really make any sense. And so you can just extract these keys from a file that was shipped with this software. And there were 8 different keys. And I have published them, so yeah, there's a GitHub repo where I've published all these keys. I will post the link later. Now this AdGuard depended on a software called NetFilter SDK, and there was specifically a file called protocolfilters.dll where the keys were in. So it was quite easy. I just created a Python script that would look if something starts with the byte which is the byte that a private key in TLS starts with, and then I would pass that to OpenSSL and see if it could decode it, and if that was the case, I could dump the key. And then this reminded me of something, because this protocol filters also bundled a very old version of NSS, and I saw that before because I saw that in PrivDoc. And then I found out, okay, PrivDoc also had this shared key issue. So it was basically not only broken that it didn't validate the certificates on the other side, but it also had this shared key, which is also like adds an additional risk, because even people who have uninstalled PrivDoc at some point may still have this certificate in the browser with the shared key. So. And then I learned, is there anything else that's using this protocol filters module? And I found a lot of web pages reporting about software using this. Most of it was what's called like potentially unwanted software or crapware, like the stuff you have on your PC, you don't really know why it came there. you don't want it, how to remove it. But unfortunately, I didn't find any of these pieces of software for download. So the issue with that is these are usually companies who are only in business for a short time and then they stop. So I found a lot of information about these software pieces, but I didn't find anything for download. So if anyone has access to these things, I would be very interested. Yeah. Then I saw recently there are also people trying to do the same thing for other protocols. So this is a Symantec solution that's for email encryption. Basically, that's the thing that was PGP in the past. That's now sold as Symantec desktop email encryption. So it tells you basically to disable TLS in your email application. This is Thunderbird. So if I have this installed and try to set up my email in Thunderbird, it tells me to disable TLS encryption, and then it will intercept that email, encrypt it, and do a connection to my email server. Thunderbird then shows this very scary warning, which is completely the right thing to do. I mean, you're trying to fetch your emails without encryption, so it should warn the user about that. So, yeah. Then I started up a sniffer and looked like, how does this TLS connection look like? And it only does TLS 1.0 without forward secrecy. So you here have a product that's trying to sell you email encryption, and it uses a very outdated version of TLS and a very outdated cipher. Yeah. And so what kind of left as a question is that we have these enterprise appliances, which I had earlier, this picture from Blue Code and F5. I don't have access to these things, so I don't know how good or how bad they are. But I would assume that they probably have similar issues, but there's maybe some evidence. So in enterprise TLS applications, there were a lot of very weird bugs in the past years. So probably one of the strangest things that happened in TLS is that F5 had a device that if you connected to it with a TLS handshake that was larger than 256, but smaller than 512 bytes, it would not do a connection. This was a big problem when people tried to introduce new features into TLS, and then the handshake got bigger and these F5 appliances wouldn't allow connections. So what happened then that now there's an extension to pad the handshake. So this is, I think, the first time that there's an explicit TLS extension only for one bug in a certain product from a certain vendor. So yeah. Then I also mentioned earlier this POODLE TLS issue. So people were able basically to port a bug from an older version of the SSL version 3 bug to the newer protocol TLS. And that was found in a whole range of devices like F5, A10, Cisco, Checkpoint, Juniper. And these are very often, these are the companies that are producing these enterprise interception devices also. And something that came out very recently is a bug called MACE, where devices would not check the MAC, so they wouldn't verify if the connection was, if the data was correct at all. So I would not trust these companies to intercept my TLS traffic. So, and then you may ask, what's the alternative? And I think, first of all, this may be the wrong question. Because a lot of these products, I would doubt if they should exist at all. And this is quite obvious for something like Superfish. I mean, it's a software that gets installed on your laptop without your consent, and that's showing you some ads. I don't think there's anyone, or is anyone in the audience who thinks they need more ads in the internet? I don't think so. But also for things like if you have these firewalls or antivirus applications, really, I want to ask the question, is it a good idea to inspect the traffic with antiviruses basically don't really work anymore? I don't know if they ever worked in a reasonable way. So for many of these products, I would just question, is this a reasonable way to do IT security? And if you're breaking encryption, then you're introducing a big risk, and if you're doing that for security, seems very questionable. But there are, of course, legit reasons why you want to modify traffic in some way, But if you do that, then please do it after the encryption. So what you can do, of course, is a browser extension. There are a lot of things that do that, like HTTPS everywhere, or like Privacy Badger, or things like that. But especially this should happen with the user's consent. So, and then this is fine. Yeah. So my takeaways are kind of, I think this issue with these potentially unwanted applications or crapware or bloatware, however you want to call them, is a big security threat, and it's not really, it's underestimated, I think. So the idea that you're paying a laptop vendor to install some software on the device that nobody wants, that's not a viable, that's not a legitimate business model. And also the idea that you're bundling a software with something else and then tricking the user into clicking OK, and then you can say, OK, the user consented to it, but these are often made in a way that it's very easy to click on the wrong button. Like, you may have heard that SourceForge now had kind of taken over a lot of free software projects and is now providing installers that are shipping some other software with it. There was recently GIMP found out that there were GIMP installers on SourceForge that were bundling something and they didn't know about that. So this is really not something that's absolutely not acceptable, I think. So if you want to install a software on another person's computer, you need their consent, I think. And that, yeah. And this whole TLS interception issue, I think it is generally dangerous. I have not seen any software that gets it right, and even a lot of security products don't get it right. So I think it's completely a misguided approach. The encryption is there for a reason. It's there to protect your information and to guarantee that the information gets transmitted unmodified, and that shouldn't be messed with. Yeah. So here's, as I mentioned earlier, the GitHub repository where I collected all the certificates. And now I assume we were faster than I expected. So we have a lot of time for discussion. Yeah.
Yeah, thank you for this talk. I think we learned a lot. And there are already at least 3 questions. We start at the left.
Hello? Hi. Do you think it would be a good idea for all browser vendors to offer either an extension or an API for software vendors which works that they submit all the traffic in addition to somewhere else, so like a span port on the router? So that you have a common API?
Yeah, so basically you want something like a browser extension, but that's across all browsers.
Yes, because it seems to be the case that vendors want to have such a functionality.
That might be an idea. I haven't thought about it, but might be a viable idea.
Next one also from that side, because there's nobody lining up.
Okay, thanks a lot for the great talk. What I was wondering was really related to the last question. So I think we all agree on superfish, etc. But blue code, I think there's like a legitimate compliance need. And there are companies who want that kind of SSL interception. So saying just don't do it at all, I think would be nice, but don't work. So maybe we should go away from it. Maybe we should have like an explicit standard to share the TLS secrets with a trusted party. So if I have in Chrome a special field in my address bar which says, hey, this is monitored by your blue code appliance from your company you're working at. I think that will be better or more interesting than the approach we are going for, or what you pushed for, saying, well, that's evil practice, don't do it at all.
So what you kind of want from me, that I make proposals how to fix something I don't like. And I think it's generally wrong. You want to have a better solution for something which I find illegit in the first place.
Yeah, no, I mean, your point is that you don't like it, you want to get it away, right?
Yeah. So I won't make proposals to do something better that I want to get away with.
But from a practical point of view, it's not going to go away because there are companies who have a need. So I'm asking, why don't you go forward and say we should have a better standard, a better way to do it, rather than just ignore it at all? Because let's say you try to ignore the issue that there's a need for it.
So you can try that, but I won't do that. And
Okay.
I won't propose anything that I think shouldn't happen in the first place.
Fair point.
Now a question from the right.
Hi, I'm really curious about what kind of need you have to break TLS. It's not a question for the speaker, but for the guy who just went away.
Yeah, you come back, please, if you like.
Thank you.
So I'm involved with SSL interception a bit, but doing open source work only. I have no commercial interest in that. But my point of view is that the issue is if you do SSL interception in the traditional way, like doing two kinds of connections and have like explicit SSL certificate management on the proxy instance, then you get these issues which we have with Superfish, etc. If you have a legitimate side channel where you would leak like the TLS master secret, then you would get at least a very explicit way, and you would still have a connection end-to-end, but with a third party that could listen in. I think protocol-wise that would be more interesting. For HTTP 2, there was actually a RFC on SSL interception proxying, which had a lot of debate, and I think
that was only for opportunistic encryption. So that was not for explicit HTTPS connections.
Yeah, sure.
So,
but, I mean, Bluecode, etc. have a business case for that, and it's not going to go away. They're still going to do it. So I think you can't just push it away. And that's basically the issue.
Please go to the microphone if you want to say something.
Just for the record, I don't like it myself. I would be happy if it goes away. But for companies, there's a compliance use case why they're doing it. And if you ask those compliance guys, they will say, well, we will continue doing it. And like getting this away is, I think, way harder than like going over to a better protocol.
so
Sorry, can I just, you're not going to make it go away by inventing technical solutions that make it better when it stays. So the way to make it go away is to make the technology go away. You don't have that trusted side channel. You don't put that law, legitimate access law enforcement kind of thing into the protocol. You make a secure protocol and you implement it. And people will live with it. People will deal with it. If you implement that, you'll just get more intercepted connections, not fewer.
I think we could Pano give a try to answer this as well.
yeah. And so I also want to say, like, my hope is that if we do more analysis on these things, I expect we will find more vulnerabilities, so we can have more, like, get these devices a worse reputation. That would be my approach to it.
Maybe I can again say something to this, because I see the point, and if we start and have a super protocol which does not allow such a thing, then people or vendors will start to do, as you said, build a browser extension which is doing the same thing. And I think that's especially what he wants to have, a common way of accessing everything. That's just the thing. Okay, we are moving forwards, but either we can say, hey, vendors, think of another way because we disable your old way, or we say, hey, this is a better way, maybe you use this one. Either be constructive or not.
Was this a question, or? So, I mean, yeah, so, I mean, the first question I always want to ask is this product doing something legitimate at all? Because for a lot of these products, I think the answer is no.
Yes, but people pay a lot of money for this product. So
yeah.
Obviously, there is a market for this, and they will not stop paying money for it.
So now the person in red who's waiting a long time now.
Yeah, it seems like I'm going to be on the side of poor interception in a way, because I just like to remind people that not everyone has 40 gigabits per second anywhere. Where I work for, we have really expensive boundaries. It's with a huge latency, and the current web really works badly overall. And each time we add encryption or more generally TLS, and we'd like to have proxy for the users, which they would opt in, but in an easy way. And currently, with more TLS, we have more problem doing it. I'd like to have a really clean solution rather than a hackish interception. But so far, it seems like there are people who are comfortable in their living room with really good internet access, and they are just thinking about adding encryption, but not thinking about others. I don't want to do man in the middle at all, but it's a bit easy when you have a good connection to forget about others. And yeah, that's it.
Oh. Yeah, I think there was no question. Or yeah.
No question, just a comment, because I think we're a bit privileged here, and we should think that proxies can help sometimes.
So your issue is that proxies can cache things, and they're
that would be one use, yeah.
Yeah. So the issue with caching is that you can cache less and less anyway, exactly. Because content is getting more dynamic, and caches have very few uses these days. So I think the increased security from TLS, and also if you do things like HTTP2, where you have performance improvements through TLS, are much bigger than what you can gain with caching.
I don't completely agree. I see your point, and definitely with Web 2.0 we have less and less caching, but then we have some fairly large media which could benefit a lot from caching.
Okay, the next question from the right.
Okay, I just wanted to add some points. How I came across this man-in-the-middle attacks from antivirus software, I think with VAST, because they break client certificates. I think that's something that wasn't mentioned.
Okay, no, I didn't notice that. Thanks for this note, yeah. I looked at Avast, but I didn't notice that they break client certs.
Because the client certificate is obviously in the browser, and the antivirus software doesn't have, or doesn't check for that.
Yeah.
And do you have any ideas how to prevent any interference from local processes in the TLS session? Do you have any ideas? Because I also think that this is a bad practice and shouldn't be done, and then a common interface would just be misused by ad injection software.
So, I mean, this only can happen if you have some access on the client, right? So this software must install something into your browser. So the solution is basically be careful what you install on your computer. I mean, if you install bad software on your computer, then it can do bad things.
I understand, but if we have a corporate environment where such a SSL injection is common, and the user probably doesn't have any meaningful way to influence what is installed on the computer, that maybe we can do something on the browser side, so it doesn't even. It's not very easy to do such things.
So there's basically no way, if you have a software on the client that wants to mess with your browser, there's no way to stop that. I mean, that's basically the malware problem. If you have something on your client, then it is in control.
Yeah, okay. Good point. Thanks.
Yeah, there seem to be no other question at the moment. Oh, there's one.
Hi. When it comes to TLS security, why can't I pin a key to a site? And why can't I look up the key fingerprint?
Well, you can pin a key to a site. So if you're the site
I mean
or...
a key and not a certificate.
So the way this key pinning standard works is that it is pinning the key to a site.
And you're wearing a Firefox t-shirt. Firefox doesn't support this.
Firefox supports this since 2 or 3 versions.
Okay, I'll come back to you and you will show me.
So there's this HTTP public key pinning standard. It's an RFC now, and the idea is
by the server.
Yeah.
Yeah. No, I'm a user.
Okay.
I, the user, want to pin a key to a site, and I want to see it so I can check it manually.
Yeah.
And this is not possible, and I don't know why, especially because I can see the fingerprint of the certificate.
The problem with these, so you think about things like certificate patrol and similar plugins, right? So
I don't.
I
think this one uses a notary service. I don't. I'm not talking about notary services.
There are some usability issues with that, because if the certificate changes, what do? You don't know if it's a legit change or a malicious change.
I have a chance to check it, and I have a chance to check with my bank. For example.
I'm very skeptical about any solution that requires the user to know what a certificate is, because that's not widely usable. But we can discuss that later.
Okay.
Okay, that seems to be the last question. Yes. So, please, again, a big applause for Hanno.